Yeah, hi, good evening all from MindMajix. So today's demo is on Clojure. So moving to next, let me introduce myself. I have a total of around 6 years of experience in IT industry, and I have worked in both product as well as service companies, which do provide different experiences. And I like to learn new technologies and always try to be updated with the new technologies in the market. So technologies on which I have worked on are Python, Clojure, Java, Golang, and databases, and there are other technologies. And I like to basically, learn new things, and whatever I learn, like to learn that deeply, so that I can share my knowledge. Now, the scope of this demo will be the introduction to various data structures which are there in Clojure, and where can we use that data structures, and where to use that data structures. So these are the points that will be covered. So the course outline will be Clojure fundamentals, functional programming, what is functional programming, the basics of Clojure, then introduction to Lean. So Lean is a kind of a tool which is used for the Clojure. So that we will also have an introduction to that. Basic ADAS is nothing but some of the programs, basic programs that you need to learn while learning a programming language. Second, what is a function? Next, what is a functional programming, basic, intermediate, and advanced level? And we will also learn to build Clojure web APIs, and it has different technologies like GraphQL, Ring, REST API, Compojure. Atomic is kind of a database which is written in Clojure itself, and it runs very well with Clojure. And the authentication in the web API, we will also learn how to connect to the SQL databases, and also the configurations for different environments. The Clojure script is kind of different altogether. It is kind of a Clojure, but it is mostly used in the website to develop the UI part. We will also have a look at that. We will look into shadow CLJs. We will look at Clojure script basics so that we can learn some of the points for the web UI. And finally, we will also learn how to implement a web UI in Clojure script. Now, there are certain add-on topics which I will like to add in the course, which are important from the Clojure point of view. The first is introduction to macros. So macros are really interesting thing in Clojure, so we will learn about that, and how a polymorphism can be implemented in Clojure. So which is an OOP, which comes in object-oriented programming part, but it can also be implemented in functional programming language such as Clojure. So we will see what are the various ways through which we can achieve this. And additional course resources, I have given, and then you all can go through this course resources, and you all can learn. You all can, if you have curiosity about it, you can just surely go through it. There are two projects that we will be working on. The first project will be implementation of APIs in Clojure. So in this, what we will do is we will create a backend APIs using Compojure tool. And the next is Clojure programming problems, where we will try to solve the basic programming problems in Clojure. So which will give you a good sense onto it. Now for the lab setup, the first thing prerequisite are you need to have a good internet speed, and you need to have a desktop or a laptop. And system requirements for it are, you can have Linux, Mac OS, Windows 10, or a mouse system. Now Linux and Mac OS are the preferred one over here. I am myself using Mac for it, and the disk space is around 500 GB memory and 4 core CPUs. That is a basic requirement. Now, in the end of the session, when we will complete the course, in the end of the course, we will also have the mock interviews, which will include, all that is covered in the session. It will be kind of a brief learning for us, whatever, what is that we have learned about it, what all we were able to grasp from the whole lectures. And it will also include some extra add-on topics, that we have talked about, like macros and polymorphism. Now it will be combination of quiz, theory questions, and programming questions as well. So with now after having a mock interview, it will really boost your confidence, and it will help you know what are the things which you need to work on. Now, if you talk about the certificates, if you are interested in certifications, you can go for this one. This is one of the good course, that is Clojure from beginner to advanced, which is there on Udemy, and you'll get a certificate for it too. Now, on course completion, you will get a certificate from MindMajix, which will identify you as a certified Clojure developer. And now, what we will do is we will just go with some of the stuff which I wanted to show. As I said, in today's demo, what we'll be doing is we will be considering the data structures in Clojure. So if we have Word or any other languages, data structures are nothing but some of the way through which we can actually store data. So this is one of the good sites which I have, which is there on online. So when you can use that. So different kind of data structures, if we can see, are Boolean type. Boolean is kind of truthy and falsy value, where if you can define the truth and false. So in Clojure has a really good thing. It's known as REPL and REPL, using which we can execute our Clojure statements. We don't need to write the whole project, and we don't need to just to see how particular thing works. So lean is a tool which we have talked about, and lean REPL is a command through which we can start the Clojure REPL. So in this, if you see, there is nothing but it's kind of a UI, I mean, command line program that has been given to us. REPL is a command line program that has been given to us, through which we can practice some of the things that we want without even creating a whole project and everything. So the first thing is, whenever you want to define any variable or something in the Clojure, then the first thing that you need to do is you need to use a keyword known as def. Then the name of the variable that you want to use. Suppose we want to use a, and the value of that particular variable you want. So suppose if I want to use 10. Okay. So this is, so as we can see, this user that we can see is nothing but a namespace enclosure. We will come to that later. So in the namespace, we have defined a variable named a with a value 10. So if I write a again, it will print the value of it. Okay. So this is kind of, this is how we can work with variables in Clojure. As we were speaking about the Boolean variables, so there are two values that are there in the Boolean variables. First is true and the second is false, obviously. And the keyword that is used is Boolean. And there is one more interesting thing to know in Clojure is except false and nil keyword, everything else is true in Clojure. So if I say, suppose if we want to, so everything is regarded as true, everything is evaluated as true except false and nil. So if I want to use a Boolean variable, what I can do is I can directly write Boolean, it's small b, okay? And similarly, we can also, we can also see what is the value of Boolean 0. Again, true. But as I said, if we go for nil, it will give us as false, because in Clojure, nil and keyword false are evaluated as false, except that everything is evaluated as true. So going to the next part, as we all have worked on, some kind of strings always. So there are different ways through which you can define string in Clojure. The first way is, just writing a string like hey, hello. So this will directly print a string. This is one way. Secondly, what you can do is you can use a keyword str. Now this str is nothing. It can be used to concatenate two strings. Like I said hi, and then I said hello, and if I print it, let's say something over here, I missed the code. So I'll say str hi hello. Yeah. So it's now concatenated. I wrote two different strings and then I concatenated it using the string. And as you can see, you need to put the space, by yourself. It does not add and space, so you should put that whatever separator you want to wear. So next, there is a format. So what this format does is, suppose you want to concatenate a string, and you need to concatenate, it's a long string, and you need to concatenate different at different parts of it. So what you can do is you can just go ahead and you can use this format. Then you will say my name is, this is nothing but a placeholder, and later you can just write whatever string. So I'll write. So as you can see, I haven't, I just added a placeholder to it and it added Ruby to it. Now it can be used when you want to, directly add a value from the variable to a string. You need to concatenate in that way. So this is how formatting can. Now next, let's move to the next topic. sorry, the next data structure, which is nothing but the integers. So we have, work with integers. So integers are nothing but, other numerical values that are there. And so if this 0, 1, 2, or -1, everything that is considered as an integer. But in Clojure, if you see, there is a different way through which you can add these integers. The first thing is to add an integer. What we do normally is, in any other language, what you will do is 2 plus 3. Okay. Now in Clojure that doesn't work. Now in Clojure, how the things work is you need to first add the operation that you want, then you can add the numbers that you want to add. Just give it 5. So this is how it works in Clojure. So this is how the addition works. This is how the subtraction works. The multiplication works the same way. The division is done with the forward slash. So you can just give the forward slash and the two number to which you want to divide. This is the first number and this is the second number. So remember the order in which you add the numbers. Now you can also add the modulo. Modulo is nothing but operation which actually returns you the remainder. So you can add that also. Now max is nothing but a function that has been already created for you. So whatever, so suppose if you want to give them a list of numbers or something, and you add a max to it, it will return you the max value out of it. Now min is also the same kind of function which is written. Now there is nothing like power or raise to in Clojure. So you need to write a function, or you can directly there are other ways. We will look into it after that. So basically here what we are doing is we are just creating a function known as power, and later we are passing these arguments to it. But since we haven't gone into function at all, I guess we can discuss this later. Now there is one more, that's known as big int. Big int is used to store big integers. Okay, so there is a certain limit for the integer to be stored. So what we can do is this is the so basically this is the limit. If you go beyond this, you won't be able to store int. So in that case, you will get this arithmetic exception. That is the reason what we do is we can use big int over there. And in this big int, we need to use n. So n is nothing. If you all have worked on Java, you all might have known that you all can use L for long. So similarly, you all can use n, which will tell Clojure that it is not just an int but a big int. Now these are the basic things through which we have gone. So there is one more thing I'll like to show you all. So there are also float. So there is a keyword known as float. Using the float, you can define float numbers which have precision to it. Later we have lists, and now these are the advanced data structures. If we go into the advanced data structures topic, so in this data structures, there is list, there is vector, sets, map, and sequences. Now, what a list? So, lists are the most basic collection in Clojure. So, if we have this, so this Clojure is a Lisp language. It is a derived from the Lisp dialect. So, all these languages they have one thing is common. Thing in common is that they evaluate lists. So they are evaluate. So if we see the syntax of Clojure, you will be able to see that everything is written within this brackets. This brackets are nothing but kind of a list. Okay. So this is a list data structure. So everything, so your each and every word in a Clojure is represented as list. Now there are different ways through which you can use list. So if you can see, I need to add this. I'll show you all the example. It's 1, 2, 3. If I put this, I'll get an error because in Clojure, what happens is it directly evaluates whatever is there in the list. Okay, so if you want to create a data structure of list, you need to just tell them using a single quote that don't evaluate it. It is just a data structure, and yeah, this is what we. So during print, we won't be able to see the single quote, but this is used for the Clojure compiler to know that this has not to be evaluated and it is a list data structure. So this is how it works. And there are different operations which are there in this. So in Clojure, each and everything is immutable. Immutable means whatever you define or you declare, you cannot change the value. So if I write def a is 0, now there is no way I can, and a is 0, there is no way I can change the value of it. If I use a single equal to like other languages, and if I define a value up to 2, basically it will just try to say that it will just check whether a is equal to 2 and return with the false. So there is no way you can change the value of a variable in Clojure, because all the variables in here are immutable. Immutable means their values cannot be changed when defined. So if you want to change the value of a, you just need to define a once again. This is how it works. Now the a is 2. So similarly, the list and all the data structures in Clojure are immutable. So if I say, so as you can see, if we are not adding a single quote to it, it will just give a class cast exception. So there are certain operations that can be done on a list. One is conch. Now to add a value to the list, use conch. Note that the new value is to be added to the top of the list. So if you see, this is a list of 1, 2, 3, and we are trying to add 4 to it using the function known as conch. Now what it will do is it will add the value 4 in the starting of the list. Now, as we have discussed that it is immutable, but yet we are changing the value of a list, right? No. What we are doing over here is internally what it does it creates altogether it creates a new list itself, and it keeps on adding the values to it. So it's not the same list that we had. It's basically a new list internally which has been created, and it has been reassigned. Now there is no way you can remove the list element from the list. Okay, we will see to it how it can be done. There is a workaround to it. And if we want to get the nth element of a list, we can use this nth keyword, which will give nothing but a particular element. So if you see, if I want the first element of the list, it will give me 2. So because the indexing starts with 0, 1, 2. So the first element, the first nth element of the list is nothing. It's 2. Okay. Now there is one more function which is there known as count. Now if you use this function, it will give you nothing but the total count of the list. So total number of values, or total number of objects in the list, total size of the list. So size of the list is 3 because there are 3 elements. Now we will move to the next data structures, which is vectors. Now, so basically vectors are nothing but a more efficient way through which you can use lists. So there are certain operations which are not permitted on the list, or internally how they work. The time complexity to add an element to the list is comparatively greater than the time complexity that is there to add element to the vector. Okay. So the first thing that we will see is what are vectors. So if you see in the lists are defined using this parenthesis, while the vectors are defined using the square brackets. Now, using the square bracket, we can the compiler knows that this is not a list, but this is a vector. Sorry for that. So we'll be just, this is how we will be defining a vector. And if you see in the vector, we don't need to add a single code to it, because it is not to be because the compiler will not directly just start and evaluating it, because as Clojure compiler directly evaluates the list, this is not the same case with vector. So in vector, it is not necessary to add a single code to it. Okay, and so this is how a vector is defined. So if we see, this is how a vector is defined. I will just say a vector as 1, 2, 3. If I print v, it is nothing but a vector. Now there is one more, this conch, which is used to basically add an element to vector 2. But the difference over here, then the list, I mean, we were using the same in the list also. Conch was used in the list also. But the difference over here is the element is added to the last of the, in the end and not in the beginning, unlike the list. So if I write conch and try to add an element to the existing vector, then that element will be added to the end of the vector. Now again, we cannot, there is no way to remove element from the vector. Now this is a different story we will look into. And yeah, so nth is again, using this nth operation, what we can do is we can get the nth element of the particular vector. Okay? We can also use keyword like first and last, which are inbuilt keywords. So we can directly use that also. So for an example, we have created a vector v. So if I write first of v, it will give me 1. Correct? Now if I write n of v is 1, then it will give me 2. correct? Because it's 0, 1, 2. If I write 0, it will give me 1 because this is the 0th position. Now index of is another function that can be used. Just note that we are using the dot before it, and I'll tell you in the further lecture why we are doing that. So index of 2, I mean index of 2. So basically over here we don't give the position but the element itself. So if I write dot index of b, and the elements are 1, 2, 3, so I'll write the index of 3. Over here, I need to add the index, so it's all a different story how this index of can be used. Yeah. So yeah, it's 0, 1, and 2. So basically I just need to add the element and not the position over here. What I am trying to ask, to the function is that give me the index of this particular element 3 inside this vector. So if we can see, it's 0, 1, 2, it's in the second element, so it will return 2. So using this function, we can return basically the position of the element. Now now we are done with the vectors. Next, we will move to sets. Now sets are the kind of data structures which are defined using this curly brackets, and it can be defined using this hash. So as we all know, the main property of the set is you cannot have duplicate elements in the set. So suppose if you want to declare a set which has same element twice, then in that case you will get an error that you cannot basically have say you cannot have repeated elements in set. And using const, what you can do is again you can use const to add element to it. And one more thing that we need to know about set is the order of the elements inside the set is cannot be guaranteed. I mean, if we write const this over here, maybe we can get a different value also. So it's not necessary, that order is so there is no particular order to it. Okay, it can be saved in any order. And again, if you are using const, okay, to add an element to it, once if you are trying to add an element twice, and if one of the element is already ignore it, not add that element, and it won't give you any error. Now there is, in all the data structures earlier that we have seen, there was no way through which we can just go ahead and remove an element, from the data structure. But instead, it is possible using the keyword known as disjunction. So basically, what it does is it just basically removes the element. Okay, you just need to give what element that you need to remove, and it will remove the element. If that element is not present over here, in this example, we are trying to remove 4, but if the 4 is not present, it will not throw you any error. It will just, return you the list. So there is one more thing known as sort. As I said, there is no way we can guarantee the order inside the set. So what you can do is you can use a keyword sort. But if you observe correctly, what is happening is when you use sort, the return it will not return a set, but it will return a list to you. That is the reason it will be, sorted. But in the set you cannot. So this sort will return you a list and not a set. Okay. Then there is one more different keywords that are there. There is a function known as contains. So contains question mark. So this is the whole function. You I mean including the question mark. It is included in the name of the function. So using contains, what we can do is we can find whether that particular element is present in set or it is not present. Okay. So here we are trying to find that whether one is present in this set or not. So here it is returning true because it is present. And when we try with element which is not present, it will return false. Now subset. Now subset is nothing but it is also a boolean function. So what it will return is it will just return here. What we are trying to do is we are trying to say that is 1 and 2 is subset of 1, 2, 3, 4. So yes, 1 and 2 is subset of 1, 2, 3, 4. So it will return true. Now if we say 1 and 5 is subset of 1, 2, 3, 4, no, because 5 is not present, so it will return false. Now superset is nothing but the set which has more element as compared to the other set. So what we are trying to do is we will say that 1, 2, 3 is a superset of 1, 2. So yes. So this is how it works. So these are nothing but contain subset and superset are nothing but functions which are there in which are specific to sets. Now the next data structures that we will be moving to is map. Okay, so if we have worked in Python or any other language, you all know that there is a data structure known as dictionary, or there is, so basically it's just a way to store key value pairs into it. So what happens is, if you see the declaration over here, now this is kind of a keyword, okay, keyword enclosure. So if you are saying that Apple, Mac, and Microsoft Windows, what it will do is basically this is just a one value. This is one part. This is again another part. So this is the key and this is the value. So you can directly get the value if you call that particular key. So it's same over here also. Although it's not a keyword but a simple string. So here it is key, but it is in the form of string, and this key is in the form of keyword. Okay. Now this is how a map is defined, and there is a difference in map and set. Both are there, defined using the curly brackets. But as I said, set are nothing but they are just have this individual values. But maps are nothing but the whole single value of a map is nothing but the key value pair. Okay. Now there is a key function known as get. If you use that function on a particular map, so as I said, this apple is a key for Mac, correct? So if you say get apple, so what it will tell to the compiler is get a value for this particular key. Okay. So this is a map which we are referring, and it will tell to the compiler that give me a value for this particular key, and it will return back. So this is how it works. So if you try to get a key which is not present inside a map, then it will return nil. Okay. And if you don't want to use get, there is a shortcut to it. You can directly ask for a key. So if you define a key outside, it will directly give the value of that particular key inside the hash map. So another function which is used vastly over here is assoc. So as we have seen, const keyword was used in list and vectors if you want to add anything to it, right? Similarly, assoc is kind of, if you want to add a new data pair of key and value, then in that case you can use assoc. So if I use assoc on this map, and I'll tell it to, sorry, on this map, and I'll tell it to add this new key value pair, so it will add. So as we can see, this is again our key value pair that has been added to this map. Again, if you are trying to, if you're using a assoc, and if that key is already present, then it will just update the value of that particular key. As you can see over here, it was Mac, and we tried to use the assoc key, function on this particular map for the same key which is already present. Then in that case, it won't add it, but it will update the value of that particular key. So the Mac got converted to iOS. So there is one more function known as merge. Now merge is nothing but this is a way to now difference between assoc and merge is assoc is used to add a particular key value pair to an existing map, while merge is used to merge two maps. So this is a different map, this is a different map, and when you use keyword merge to it, it will just merge the both maps. Okay. So this is how it works. Now keys. Now if you want to get all the keys which are there inside your map, like Apple, Microsoft, then in that case you can use keys function, or you can use values to get all the values. So this is the data structures we have spoken about, and the one more thing is sequences. Now sequences is altogether another topic in itself, so we will discuss this in some other time. But yes, it is kind of really interesting topic to look into. So do you have any questions or anything that you'll want to ask? We can look at. I just stop sharing my screen. Okay, thank you guys. Thank you for joining today's session. Thanks for attending the demo. Please share your feedback and contact us for the queries related to course scope, schedule, references, cost, and payment options. You can also send an email to info@mindmajix.com, and the contact number for India and USA is there on the slide.